Okay, you all have this Excel output just I did here, especially with the names on it. NPI here. You have to include NPI here. I don't change this one by myself. Okay? You know, I show you how to do it again, okay? Go back to my original data, then data analysis, then choose the regression, okay? When I put my Y, the range of my Y is including the name of the variables. You have to include the name of the variables. So, sorry. What's wrong with this one? I have to include the name of the variables. Also, there's a column here, say label. I have to click the label box also. Okay? Then all the output will be on the new sheets. Okay, after I do that, then I will have the output something like this one. Okay? And if you compare the result of this one, exactly same as the eViews, except they do provide these parts. Okay? These parts automatically, they have the 95%. And since my alpha level is 95%, so I didn't change the confidence level. But suppose I'm working with alpha is 10%. Okay? I'll let you see the difference. Okay? You know, it's weird to see there's a two, one is 95% and there's another one is 95%. This is because I didn't change my confidence level. If I change it, you know, this is default. 95% is the default. If I didn't change it, they show twice. But I change it. It shows on 95% always. Then the new confidence interval. So suppose, okay, if I go back to my original data, and if I change this confidence interval from 95, did you see that? The default is 95. If I change it to 90%, you know, I just show what I have here. Then I'm using OK. Then there's a new variable. This one, they shows 95% and also the 90%. So you see the difference. Okay? Here is 95 and 90% since I changed the confidence interval, confidence level. Okay? All right. And let's come back to the 95%. And we are working with the variable, the coefficient with I. So it's this one, right? Okay? And if you look at the textbook, how do I get this confidence interval? Okay? So on page 157 with equation 5.9. You'll see that? How do they get these numbers? It's using beta, since this is beta 3, right? Beta 3 hat, then plus and minus critical value, plus and minus critical value, then times standard error of the beta. So in that case, what is the beta 3? This one. So 1.28 something, okay? I didn't write down anything. I just write down 2 decimal places to save my time. Plus and minus, what's the critical value for alpha level is 5? 1.699, right? Is that right? 1.699. So it's a 1.699 What's the standard error of the beta 3? It's this one. This is the standard error of the beta 3, this one. Okay? So use this one times 0.45 something. So using these formulas, it turned out to be these numbers. Okay? That's why I'm saying that I like to show the Excel file. I don't see that from the eViews, but I can see it from the Excel file. Okay, so you don't have to compute it by yourself. You can use the Excel, and you can have these numbers. So what does that mean? The confidence and 95. Okay, what is the confidence interval? What is the confidence level? You remember, alpha is significance level, right? 1 minus alpha is confidence level. That's why we're saying that this is the confidence interval. So we have the lower and the upper, since it is an interval. So lower end and upper end. Okay? With these formulas, you can calculate the lower end and the upper end. So in other words, this means that the beta 3, look at this expression. Based on our data, the estimation of the beta 3 is between 0.1767 something, okay, up to 2.399 something. Okay, so what does that mean? What does the confidence level mean? What is the confidence interval mean? This means that based on our data, okay, the beta 3 hat the estimation of the beta 3 hat, I have 95 confidence that the estimation of the beta 3 hat is between these two numbers. Okay? In that case, does 0 contains in this number, in this interval? Does 0 contains in this interval or belong to this interval? 0, because we're checking with the 0, right? Does the 0, because our null hypothesis for beta 3 is not equal to 0 and beta 3 is equal to 0. This is what we do, right? Does 0 included in this confidence interval? No. So since 0 does not belong to this interval, okay, I didn't write on it. It's write on it by yourself. Since 0 does not belong to this interval, therefore reject null hypothesis. Okay? And whatever approach, critical value approach, p-value approach, confidence interval approach, when you're working with two-sided, the conclusion will be the same. They will not conflict. They just use the different way to do the hypothesis testing. It won't affect the result. It won't affect your conclusion. So when we say there are 3 ways to do it, means what? They will have the same conclusion. Okay? Understand what I'm saying? And this confidence interval, since we're working with an interval, it only refers to two-sided test. If you're working with one-sided test, we don't check with the confidence interval, since they're just one-sided. Okay? Any questions from this confidence interval approach? So actually, working with a two-sided test. Okay, this is what, and I show this one again here. Decision rule for two-sided test. I have critical value approach, p-value approach, and confidence interval approach. This CI means confidence interval approach. Okay, then critical value approach and the confidence interval approach shows the beta will between this lower end and upper end. So if the confidence interval contains the hypothesized zero, do not reject. If the confidence interval contains hypothesized value of zero, do not reject. And since zero do not belong to this interval, so we reject the null hypothesis, right? So otherwise, reject. Okay? All right. So this is saying that the hypothesis testing with two-sided test, we can use another approach called confidence interval approach, which covered in our textbook 5.5. Any questions so far? Then I will also cover one of the tests, which is called the whole models test. What do we mean by whole models test? Means I will check whether this model is good or not. So far, we are working with individual variables, right? We didn't see the whole model at the same time. So if I wanted to see the whole models, okay, in this case, in UDI 3's case, what is the null hypothesis and alternative hypothesis? Okay, let me show here. Maybe I don't have this one. Okay, let me go back here. Okay, this is the UDI's. Okay, if I want to do the whole models test, so this is in our book 5.6. We call it F test. Okay, and step one. Step one, null and alternative hypothesis. So what do I say from here? What do we mean by the model is good or bad? If this model is useless, what do I mean? Means all the beta equal to zero. Okay? If model is useless, all the beta is zero. When the coefficient is zero, what do we mean by the coefficient is zero? Means there's no relationship with individual independent variables, with the y variables, right? Right? So null hypothesis will be the model is Useless. Then how do I state alternative hypothesis? We say that null hypothesis and alternative, the union of the null hypothesis and alternative hypothesis is the whole story. So this is useless and this should be useful, right? So it means that at least the 1 beta is not equal to 0, then this model is useful, right? Okay, so we're saying that at least 1 beta j not equal to 0, j equal to 1, 2, 3. This is what we say for the alternative hypothesis. Okay, if you look at your textbook, what did it shows that? On page 162, they're using alternative hypothesis. You say null hypothesis is not true. This is not really good expression. Okay, most of the books show this way. At least the 1 beta j not equal to 0. If you like it, you can write it down. Okay, it's better to express in this way. Okay, so this is step 1. Step 2. Again, what is step 2? Alpha. So if I'm using alpha 5%. Okay, step 3. Test statistic. So this is what you have to learn now. What is the test statistic? Okay, here. Look at this one. This one. From the e-views, there's a F. F is a new distribution. We just learned the T distribution, right? This is another distribution called F distribution. Okay? This is degrees of freedom. From F distribution, there's 2 degrees of freedom. One is in the numerator, the other one is in the denominator. Okay, would you please turn to the table at the back from the textbook? We have 2 tables. One is called B2, the other one is called B3. On page 539 and 541. Did you see that? Okay, look at this table. Critical value of F statistic for B2 is for alpha level is 5%. You see that? Did you see the title? The title of table B2 say critical values of F statistic 5% level of significance. Did you see that? The other one is table B3. This is also critical values of F test, but 1% level of significance. You all see that? So if we say alpha is 5% using table B2, if we state it as a 1%, then use B3. Then somebody may ask me that, why don't we have 10%? Well, in our book, textbook just shows 1% and 5%. Okay? And if you wanted to have the other critical value or something like that, we can check it from somewhere else. Okay? So this is, how do we read this critical value from the F distribution? So look at B2. Okay, let's take it B2. Did you see the column and the row? Okay, from the column side, the subtotal, say V1, degrees of freedom for numerator. Did you see that? Numerator means this one, the first one. First one is numerator. The second one is go through the rows. Did you see that? V2 is degrees of freedom for denominator. Did you see that? Okay, so for example, F329, let's see. Check with the column equal to 3 and the degrees of freedom for the row, there's no 29, right? Look at the close one. So we'll see the 30, right? So what's the value do you see? 2.92. This is the critical value for 5% F distribution. Okay, understand what I'm saying here? So I'll say that this is test the statistic. Okay, F329. The number here is 15.64 something. So it's 15.6489 something, okay? So what does that mean? This means that this is the distribution. Look at the distribution of F. When I draw the F distribution, which is really different from the T distribution. T distribution is symmetric. This is skewed. It's like this way. Okay? So F, this is 329. 5%. Always on the table from F distribution is always on the lower tail. Okay? So this one, the area here is 5%. So the rejection region will be always on the right-hand side. Okay? Then what is our F? It's 15 something. And this one is what we call, what's the number? We just have it. 2.92, right? So this number is 2.92. And this is statistic. So again, using the same idea of the T distribution, our test statistic is somewhere here, called 15 something. So what is this falls on? Rejection region, right? Rejection region. Okay? Therefore, step number 3, test the statistic. Okay? Then step number 4 is conclusions. Decision rule. Okay? For critical value approach, just compare this one with 2.92. which is greater than 2.92. Always look at the right tail. It falls on the rejection region. What's the p-value? Look at this one. F, p-value, F. Did you see that? Which is, what does this mean? What does this mean? Can you read this one? 3.06 E minus 0.6. What does that mean? Means 3.06. Since this is negative E, so this means that times 10 raised to the negative 6 power. So what does this mean? This means 3.06 6 times this one. Okay? Let me tell you, okay? There's no place to write. Okay, let me write it here. Let me write it here. What do we mean by 10 raised to the 0 power? 1, right? 10 raised to the negative 1 power means 1 over 10, means 0.1. Understand what I'm saying here? 10 raised to the negative 2 power is 1 over 100. So this is 0.01. So if you see e to the negative 1 means 0.1. Okay? If you see e to the 2, I mean the expression from the output here, like this one, okay, is 0.02. So you can, like tell yourself, negative, let's say this one. Negative 1 means just 1 decimal places. Negative 2 is 2 decimal places. Oh, this is not 2, this is 1. And etc. 0.001. So this is 3 decimal places. And since we have something multiply with that, you see what I'm saying here? And what is sometimes you will see something positive, like, you will see somewhere else, like e to the positive 0.6, just using the 10 raised to the 6th power. So that's huge numbers. You see what I'm saying here? This is called scientific notation. Usually in the math. Okay, so in that case, what's the p-value here? Means very, very, very small, with at least 6 decimal places. Okay? So the p-value is so small, which I compare with the alpha is 5%. P less than alpha. Therefore, reject the null hypothesis. So reject this one. Reject this one. So in other words, the model is okay, it's fine. Means that at least 1 beta j not equal to 0. We didn't say, all of them not equal to 0. But at least the 1, then the model is useful. Okay, this is what we say the overall test. Okay, let's go back to the example we just worked it with the iPod. Do the overall test. Okay, iPod. We just work with the iPod. Okay, do the hypothesis testing for overall test. And if you have any question, just ask it right now. Okay, if you understand right now, much better, then go back home and review it by yourself and just guess this, guess what. Understand what I'm saying here? So if I want to do the overall test from the iPod examples, what is the step 1? Still 3, right? We have 3 variables, new, scratch, and beaters. Okay, work it. For hypothesis testing, if you don't practice, you don't understand it. Just you have to practice, okay? Because this is something, beyond our mind before. So always drive the students crazy, especially undergraduate students. But if you have learned this one before, I think you won't have any problems with that, right? Just unfortunately, some of you never learned this one before, and some of you learned it when you were in undergraduate, but you totally forgot. But in that case, I think it's easy to bring back those memories if you really learn it in undergrads. But if you don't learn it, there's no memory at all. So you have to learn it from the beginning. And you have to do the practicing. This is the best way to learn. Learn it immediately in the classroom. Even this is a graduate school class. Learn it in the classroom. Do not tell yourself that, never mind, I will go back and review it by myself again. As long as anything that can help you to save your time, I think that is good, right? This is what I did, state the null alternative hypothesis. So it's like this one. Beta 1, beta 2, and beta 3 all equal to 0. And the null hypothesis, alternative hypothesis, at least one beta j not equal to 0, j equal to 1, 2, 3. You have to learn expression something like this one, okay? And then, just before I forgot, 2 weeks today. I mean, December the 1st, you need to turn in another assignments, which is from chapter 5. December the 1st, okay, in the class, which in the lab number 3 on page 173. And you'll get this output, the data, I think the data from the data set. I will give you the plenty of time to work on the assignments. That's why I'm so hurried to teach this one, lecture this one today. And then I'll let you do the presentation next time, okay? I haven't finished chapter 5 yet. I still have small parts, which I have to cover maybe next week. Okay, if I still have time. I have 15 minutes to go. So step 1, like this. Then step 2. Just using either 1%, 5%, 10%. You can, I think I'm using 5%. And you can, after you learn this one, you can come back home and go back home and change the level of significance and do the practicing. Okay? So what F statistic I'm using? This is F. And what all these numbers from? What are all these numbers from? Okay, you are not able to see all these numbers from eViews, but you are able to see it from Excel. So let me show you the Excel. How do I make it? Let me do it like this way. This is UD3, right? I need to, I'm sorry. Oh, I don't have this one for my Excel file, right? Excuse me. Okay, let me use in this one. Let me. Can't do this one. iPad 3. Okay. I'll do this one. Okay, this is the Y, X means which inverse. Okay. This is exactly the same as what I have for my eViews. Okay, this is eViews. Look at this one. This is from Excel. This is from eViews. The eViews use the constant at the lower. Started from all these X variables, but for Excel, they started from the constant. Okay, so for new, there's 54 something. You know, you can check with this numbers is all the same. Okay, and where is the F value? You know, from the eViews, F value is here, right? 55.083933, right? So where is the F value from Excel? It's here. Did you see that? Then how do we get this F value? It's using this one divided by this one. And how do I get this one? It's using this one divided by degrees of freedom. Do you see this is the degrees of freedom? This is how we get 3 and 211. This 3 is in the numerator. This 211 is from denominator. And all this table is called ANOVA table. Okay, did you see this ANOVA? Means analysis of variance. The ANOVA stands for analysis of variance. Okay, so with this output, this is, and I'll show my words file. I put everything on the same screen. And did you see this one? Did you see my F? Okay, look at F. This 155, 161 divided by 3. This is all from ANOVA table and shows here 155 something. You know? So this is how I get F values. But if you don't really know something like this one, never mind. Just look at F values. But you have to know the degrees of freedom. In the numerator is 3, denominator is 211. So which is the same, which is the expression like this one. Okay? And what is the probability here? It's very, very small. Until 1, 2, 3, 4, 6, 5. Until 6 decimal places is really small. And look at this one. If you want to know the exact p-value, something like this one, e to the negative 26 means you have 26 decimal places. How small it is. So, in other words, with this, our examples, the p-value is such small, alpha level is 5%. Then, oh, by the way, what's the critical value for this, for this f? For 3, numerator is 3, and the denominator, and checking with 5% level, 3 and 120. So it's 2.68. And which we have it is 55 something. So it's far, far beyond. And it's on the rejection region. So the model is useful. Right? Any questions about this? So I have teach you how to do the individual coefficient hypothesis testing, and also the whole model's hypothesis testing. For individual hypothesis testing is do it one by one. So beta, you have to do it beta 1, beta 2, beta 3. For overall hypothesis testing is to test all the variables together. Okay? So the statements for null hypothesis and alternative hypothesis is different. Okay? In this case, since we're working with 3 coefficients at the same time, therefore, we don't split it for one-sided or two-sided because there are many, many sided. But since I have so many, I have 3 betas here. So there's no side at all. So all look at right-hand side from F distribution. So for the overall test, you don't have to see whether it is positive or negative. There's no direction at all. Because we're working with 3 coefficients at the same time. Any questions so far? So this one is on the 5.6. For the overall significance. And there's only a little bit left. Is for the partial test. Okay, I think I'll cover that next time. But next week, especially for your 3rd assignment's presentation. And if we have time left, then, or you have any questions about chapter 5, and we can continue to cover all these materials since I have a little bit left for chapter 5. So today you learn another distribution which we call F distribution. Oh, okay, this F distribution is different from T distribution. T distribution is symmetric. This is all skewed. distribution. Yes?
So for the effect, how can we make the conclusion? Is it okay if we just say that the model is useful or?
Yeah, you can say just the model is useful since the alternative hypothesis didn't say that which one is okay, right? So at least one is okay. Then the model is useful. Okay? At least one beta is useful, then the model is useful. Any questions? How many of you learned the hypothesis before? How many of you? Raise your hands. Even you just kind of forgot or something. But I think it's easy to bring it back, right? If you didn't learn it, if you didn't learn it before, there's no memory at all, right? But if you learn it before, I think it's easy to bring it back.
I haven't learned it before.
Right? So how many of you have learned hypothesis testing at undergrads? Okay, you have learned it? Then you have learned it, okay. Anybody else? You learned it. Kevin, you learned it. I know you learned it. Okay, anybody else? Nobody? Oh, you learned it, okay. So, it's okay? Not really. Okay, but never mind, we all learn it now, right? Understand what I'm saying here? You have to practice by yourself. Do not just listen to the just lectures only. You have to practice. This kind of material is something like math, okay? And also something like accounting. You really have to practice in order to understand. And you have to put the theory and the application together. Without practicing, there's no way to do. Okay? I think this is enough for today, right? Okay, then you have 2 weeks from now, this week and next week. Turn in lab number 3 assignments on December the 1st. Okay? All right, you can get the data from the class data set. Any questions? All right, that's for today. Thank you very much.